Our lesson 9.2 is about superposition of waves. Lesson 9.2 has the following goals: to explain the interference of waves and apply the superposition of waves principle, and to differentiate between constructive and destructive interference. In this lesson, you will learn what happens when two waves are occupying the same region of a medium at the same time. When this happens, the waves interfere with each other and the combined waves take on a new shape. You will learn how to determine that shape. Interference of waves. Interference occurs when two or more waves are at the same location at the same time. For example, the wind may create tiny ripples on top of larger waves in the ocean. The superposition principle states that the total vibration at any point is the sum of the vibrations produced by the individual waves. First, let's review the basic parameters of a transverse wave. We have the equilibrium line. The lowest part of the wave is called the trough. The maximum displacement is called the amplitude. The distance from one point to another point in a cycle is called the wavelength, and the highest point of the wave is called the crest. Next, let's look at the superposition of some simple combinations of two waves. The first addition of waves that will be described involves two waves that are in phase. This is referred to as constructive interference. Two waves are in phase when a crest or trough of one wave is positioned with the crest or trough of the other wave. We have here a white wave that meets with an orange wave that are in phase with each other. So this represents the displacement by the white wave alone, while this one represents the displacement by the orange wave alone. Since they are both displacements on the same side of the equilibrium line, they add together. Just repeat this step for similar points along the waves. So the resulting wave is this red wave, which is now the sum of these two waves. The next addition of waves that will be described involves two waves that are out of phase. This is referred to as destructive interference. Two waves are out of phase when a crest or trough of one wave is positioned with the trough or crest of the other wave. Noise-canceling headphones work by producing a sound wave that perfectly cancels the sounds in the room. Let's consider now a white wave that meets with an orange wave where these two waves are out of phase. So, this represents the displacement by the white wave alone, while this one represents the displacement by the orange wave alone. Since the two displacements are on opposite sides of the equilibrium line, the top one should be considered positive and the bottom one negative. So if we add these two displacements, the result will be equal to 0. Just continue adding the positive and negative together like this. Therefore, the resulting wave is this red wave that is just a horizontal wave. Finally, we observe two waves that are partially in phase. A different method of adding the waves will be demonstrated. So, supposing we have a white wave that meets with an orange wave that are partially in phase. So, we will do the addition of these two waves. At the start, it will just be the orange wave, which is downward. Then the next one will be a white wave added to the orange wave. The result will be on the equilibrium line, and so on and so forth. So finally, we have this resultant wave, which is represented by the red wave. Let us consider the following examples. In the situations below, sketch the shape of the resulting wave pulses after interference. So in the first example, we have one wave which is moving to the right at 1 centimeter per second meets with another wave which is moving to the left at 1 centimeter per second. These two waves are exactly the same. So if they meet, the resulting wave will just be an addition of these two waves. Second example, we have one wave which is 1 centimeter per second meets with another wave which is out of phase of the first wave. So expectedly, when they meet, these two waves will just cancel each other. In the next two examples, can you explain what will happen to the resulting wave pulse after the interference? Thanks for watching. Please do not forget to subscribe.